Good morning students, welcome to ABN and PRR College online classes. Let us discuss the applications of sandwich theorem. And one more example of sandwich theorem is we want to prove that limit of 1 by square root of n square plus 1 plus 1 by square root of n square plus 2 plus and so on 1 by square root of n square plus 1 and n tending to infinity is 1. To prove this limit, let us consider Sn as the middle term. This is obviously positive for every n, you know that, because n being positive, every term is positive, then overall Sn is positive. Now, let us consider again a positive integer m is such that it is in between 1 and n. It is in between 1 and n. Now, let us make the inequality so that middle, after adding n inequalities, we get the middle term as Sn. Like that we have to arrange now by adding and subtracting some values to obtain Sn in the middle. For that, let us observe Sn. In each and every term of Sn, we have a constant term is n square. So, adding n square on both sides, because it is a positive number, there is no change in the inequality. N square plus 1 is less than or equal to n square plus n, less than or equal to n square plus n. Taking positive square root on both sides, after that taking positive square root on both sides, then we get like this, same inequality, no change. Now reciprocaling on both sides, then what happens? Inequality will change. We have the reverse relation occurs because we are reciprocaling the inequality. N square plus m, n square plus n. Now we will write it in an increasing order, that is 1 by square root of n square plus n is now less than or equal to 1 by square root of n square plus m is now less than or equal to 1 by square root of n square plus 1. Take it as equation star. What is the values of m? It is in between 1 and n. Let us replace those values in star. If m is equal to 1 in this equation, then what happens? 1 by square root of n square plus n is now less than or equal to 1 by square root of n square. What is the value of m now? It is 1. Is less than or equal to 1 by square root of n square plus 1. Because in the ends of this inequality there is no m, so there is no change in the n terms. Let it be equation 1. If the value of m is equal to 2, what happens? Again we get another inequality. What is another inequality? 1 by square root of n square plus n is now less than or equal to 1 by square root of n square plus, what is the value of m? Is 2, is less than or equal to 1 by square root of n square plus 1. Let it be second equation. And so on. If we take the last value of m as n in the equation same star, then we have, there is no change in the left hand side, value is less than or equal to, only change occurs in the middle term. M value is n now, is less than or equal to 1 by n square plus 1. This is the nth equation. Because again same technique, if m equal to 1 we obtain the first inequality, if m equal to 2 then we get the second inequality, if m equal to n then we have the nth inequality. Now adding all these n inequalities, we get no change in the left and right side terms, but they are added n times, so we get n into 1 by square root of n square plus n is less than or equal to 1 by square root of n square plus 1 plus 1 by square root of n square plus 2 plus and so on, square root of n square plus n. This value is now less than or equal to right side term added n times, same term it is added n times, so this value is n into 1 by square root of n square plus 1. Let us simplify by combining the highest power term in the root, n into 1 by n square root get cancelled, so we obtain n 1 plus 1 by n is now less than or equal to, what is this value? It is nothing but our Sn is less than or equal to, here also let us common the highest power term in the denominator, that is n square, taking outside of the square root we have n 1 plus 1 by n square, which means that by cancelling n we have 1 by square root of 1 by n, 1 plus 1 by n is less than or equal to, Sn is less than or equal to 1 by square root of 1 plus 1 by n square. This is 1. To apply sandwich theorem, let us take n sequences are Tn and Un. Now let us find the limits of Tn and Un. Limit of Tn when n tending to infinity is equal to limit of, what is Tn here? 1 by square root of 1 plus 1 by n when n tending to infinity. This is equal to limit of 1 by limit of square root of 1 plus 1 by n by applying algebra of limits. Limit of a by b can be written as limit of a by limit of b. Now observe that this limit of 1, that is a constant, 1 is a constant, then limit of 1 is 1 by denominator. Let us observe that 1 by 1 plus n root means 1 by 1 plus n whole power half. By applying binomial expansion we get 1 plus 1 by 2 into 1 by n plus and so on. To take the limit of this, this is limit of a plus b plus c can be written as limit of a plus limit of b and so on. And each and every term except the first term, every term contains 1 by n. When n tending to infinity, what is the limit of 1 by n? It is 0. So here these values are 1 plus 0 plus 0 plus and so on. Except first term, all the terms will be 0. So this limit value is 1. 1 plus 0, which is equal to 1 by 1 is 1. That is the limit of Tn value. Now, limit of Un when n tending to infinity is equal to limit of, what is Un here? 1 by square root of 1 plus 1 by n square. The same manner as above, limit of 1 is 1. Limit of square root of 1 plus 1 by n square means by applying a binomial expansion, this value is except first term, remaining all terms tends to 0 when n tending to infinity. So the first term limit is 1, remaining all 0, no need to write. Here also Un is tending to 1. Tn is tends to 1 and Un is tending to 1. Then by sandwich theorem we can confirm that our Sn is also tending to 1 when n tending to infinity. That is limit of Sn when n tending to infinity is 1. What is n? Sn is nothing but 1 by square root of n square plus 1 plus 1 by square root of n square plus 2 and so on, 1 by square root of n square plus n. Limit when n tending to infinity is 1. This is the result. Thank you.